Hello, my name is Chemical Cress and I'm a scientist. And today I'm going to be showing you some of the experiments that you can do with the Colours Home Kit. So it's the Fun Science Colours Home Kit, and it's all sorts of experiments that you can do yourself at home. Inside the kit, there are lots of different things. The first thing is this really cool pair of glasses. These are called diffraction glasses, and we're going to use them later on to make rainbows just by looking through them. You've also got a felt tip pen. It might be a different colour to this, but it will definitely be a dark colour. That's really important for what we're going to be doing later. You've also got these really colourful strips. They've got all the colours of the rainbow on them. These are called litmus test strips, and they're used to find out if something is an acid, so something like orange juice or lemon juice, those are both acids, or an alkali, something like baking powder or toothpaste, those are both alkalis. We're going to be using these strips later on. And then we also have some chromatography paper, which we're going to be using with the pen to find out what's hidden inside this pen, and these rainbow spinner templates, which we're going to be using too. Now, some of those words that I've just said might sound really complicated, but once we've done the experiments, it will be really easy to understand what they mean. So we're going to get started straight away with some chromatography. That's another big word. Chromatography just means splitting up colours. Now, some of you, if you've ever done a painting before, you might have mixed together different paints to get the perfect colour for your painting. And that's what people do when they're making felt tip pens. They don't just get blue ink and put it in a blue pen. They get all sorts of different colours and mix them together. And that's how we can get loads and loads of different felt tip pens. So the experiment that we're going to start off with, our chromatography, we're going to find out what different colours are hiding inside this blue pen. So to do this one, we're going to need a strip of chromatography paper. The kit actually comes with 4 strips, so you can do this experiment 4 times with the same pen, or you might want to try it with some different pens. If you choose to do it with your own pens at home, the darker colours are the best colours, because they tend to have more mixed inside them. So things like yellow and very light pink, they don't tend to work as well. But things like black and brown and blue, they are the best colours to do with this one. So the way that we're going to do this is I'm going to start off by drawing a little circle just below the middle of the piece of paper. I'll hold it up so that you can see in a moment. There we go. So I've just drawn a circle with my pen, and then I've got myself a little pot of water like this. You could use anything to put your water in, just something nice and small, or you could put a little bit in the bottom of a mug or a drinking glass. That will work absolutely fine. What I'm going to do next is put this one in here, and you might notice that the water level is below the dot, so the ink isn't actually in the water. That's good. We don't want the ink to be in the water because the water is going to move up the piece of paper. And what's going to happen is that as the water moves up the piece of paper, the heavier inks are going to stay at the bottom because it's harder for them to move. But the lighter inks are going to be picked up by the water and taken to the top of our piece of paper. So we're going to end up with some colours up here and some colours down here. And that's how we can see what colours were used to make this pen. I'll pop this one down over here and I'll show you again in a moment once that water's moved up to the top of the piece of paper. So with that one, we're starting with quite a dark colour, and then we're using water to split that into all the inks that are inside it. Our next experiment is our diffraction, another long word. But diffraction just means splitting light. So we did chromatography, that's splitting ink and colours like ink and paint. Diffraction is splitting up light. Now with light, it's a bit strange because it's the opposite. With chromatography, we need to start with a really dark colour. Dark colours have got the most hidden inside them. We kind of know that because if you mix up all the paints in your paint pot, you'll normally end up with a really dark colour like brown or black. But if we mix together all the colours of light, we actually end up with white. It gets lighter the more light we put in. That kind of makes sense, doesn't it? We put in more light, it gets to a lighter colour, and eventually it gets to white. So you might have seen a rainbow before. When it's sunny and raining at the same time, the sun shines through the raindrops, and the sun is a yellowy whitey colour, and it splits up into all those other colours that are inside it. That's all the colours of the rainbow: red, orange, yellow, green, blue, indigo and violet. It's just the sun shining through the raindrops that makes that happen. These glasses are a little bit like the raindrops. The lenses split the light when the light goes through it. You won't be able to see this one. This is one that you really have to do yourself to be able to see it. But when I put these glasses on and look up at the lights in my ceiling, I can see loads and loads of rainbows. The white light is going through the lens and splitting up into all the colours of the rainbow. And it works on anything that's giving out light. So I can look at the window, I can look at the lights, but also anything that the light is bouncing off. So mirrors look really, really cool. Or any kind of reflective surface. The light will hit the surface, bounce off and bounce through your glasses into your eyes. And you'll see the shape of the mirror, but with loads and loads of rainbows. They're really, really cool. So we've already learned 2 of those quite long words. We've got our chromatography, which is starting to show us there's some purple inside our blue pen. So at the moment, I could see some dark blue, some purple, maybe even a little bit of pink. I'll put it back in the water and we'll look at it again later. And we've done diffraction, which is splitting up light. Now, let's have a go at putting the colours back together. So chromatography, split up the pen. Diffraction, split up the light. We're going to have a look at this rainbow spinner. So this is just a circle of paper and it's got all the colours of the rainbow. There's also a blank one in there in case you want to make your own. You can colour in each of these sections with a different colour. Now what I'm going to do is I'm going to cut this out. You might need to ask a grown-up to help you with this bit because it's a little bit fiddly and scissors can be quite sharp. So make sure you're really careful with this experiment. I'm going to cut round in a circle, just like this. So I've cut out my circle and then I'm going to put the cocktail stick right through the middle. This is another thing that it might be good to get a grown-up to help you with because it can be a little bit sharp and spiky and we don't want anybody to hurt themselves. So you can ask your grown-up to push this through here like this until you end up with something that looks like this. The stick is going through the middle. Now, what you're going to do, you won't be able to see it very well through the screen, but if you spin this really, really quickly in front of your eyes, you can sometimes spin it so fast that it actually mixes those colours together and we see white. The light hitting it bounces off into our eyes, and when we look at it like this, our eyes can see all the separate colours. But when we spin it really quickly, our eyes can't see the separate colours anymore, and they just mix all those colours together. And remember, all the colours of light mixed together, so green light, blue light, purple light, red light, orange light, yellow light, they're all going to make white. Another way that you can do this is to push it down a little bit more and turn it into a spinning top. So you can spin it on the table like this, and if you spin fast enough, you might see it looks slightly white or a little bit paler. Give that one a go, and you can also try making your own. Inside the kit, there's also a piece of paper, and on that piece of paper is a website address and a password. It takes you to a special part of the Fun Science website where you can find out a little bit more about the science behind some of these experiments, but also you can download more copies of these. So you could try all sorts of different colours. You might want to see what happens if you just do 2 colours or 3 colours, or maybe if you leave some of them blank. Give that one a go and try all sorts of different experiments. So we've split colours up from ink, we've split colours up from light, we've put those light colours back together. Now we're going to do our last experiment, which I think is the best one, because we're going to be finding out if things are acids or alkalis. You should have 4 of these rainbow strips. They go all the way from red to violet, just like all the colours of the rainbow. This is actually something called a pH scale. And a pH scale basically just means a scale that goes from acid on one end to alkali on the other end. So if something is down here, that's really, really acidic. That's a value of 1. Something that has a pH value of 1 is super acidic. It would probably be so acidic that if you touched it, it would burn. So I don't think anybody's going to have anything that's got a pH of 1 lying around their houses. And if we go all the way up here, there's a pH of 12. That would be something that's really alkaline. And that would be just as dangerous as something that's really acidic. Sometimes people, even some grown-ups, they think that acids are dangerous and alkalis are safe. But that's not true. We can have dangerous acids, right the way down here, and dangerous alkalis. Well, in our houses, we're much more likely to find things around about a 3. So 3 is a fairly weak acid. It's not too strong and it's not going to hurt you if you touch it. Things like lemon juice are likely to be around a 3. And up here, a 9 or a 10, that's a fairly weak alkali. Things like our toothpaste or bicarbonate of soda are likely to be around here. And then in the middle, we have pH 7, and that's neutral. So that's when something is not an acid or an alkali. Water's neutral, it's not an acid, and it's not an alkali either. It's right in the middle. So this is our scale, and then this one here hasn't got a number on it. That's the important one. That's actually our testing strip. So what I've done is I've got myself some vinegar. You can use anything that you think might be an acid or an alkali, but it's really important, if you're watching this without your grown-ups, that you never take anything out of any cupboards and use it for a science experiment without asking your grown-ups first. Because there are lots of chemicals around the house that aren't safe if you touch them, or they're not safe if you spill them. So it's really important that you ask your grown-up first. I've decided to do vinegar. So what I'm going to do is I'm going to pour a little bit of the vinegar into my cap like this. And then I'm going to take a little bit of vinegar on my finger. Just going to dip it in. And then I'm going to put a little bit of that vinegar from my finger onto that middle strip. So here it is. Okay. Now, what I'll do is I'll just compare that for you with one of the ones that I haven't done. So here's one I haven't done on the top, and there's the one I have done on the bottom. Now hopefully you can see it's gone a really dark orange. I can then compare that colour with all of these numbers and see which one it matches. So I think that's matching between a 2 and a 3. So we're saying that our vinegar is quite acidic, fairly acidic. It's somewhere between a 2 and a 3, but it's not really dangerous, like a 1. If it had gone bright red, we'd know we had a really strong acid on our hands. So we don't have it. It's not particularly strong, but it's definitely an acid. So if it was matching 1, 2, 3, 4, or 5, or 6, then it would be an acid. And 12, 11, 10, 9, 8, or just before 7, that would be an alkali. So we can see it is an acid. Perfect. Now I won't do too many more. I'll just leave it at that one. You've got 4 different strips, so you could try 4 different things. I'll give you a few suggestions. You could try bicarbonate of soda, if that's something that you ask your grown-ups and they've got that in the house. All you need to do if you want to use a solid is just mix it with a little bit of water first, and then put that mixture onto the strip. Chemical reactions, and this is a chemical reaction, don't work very well with just solids, so you need a little bit of water in with your bicarbonate of soda. Another one could be lemon juice. If you've got a lemon, you could squeeze a little bit of lemon juice on there, or if you've got some juice in a bottle, put a little bit on there. Another good thing to test might be washing powder. Again, ask your grown-ups for help with this, but you can mix a little bit with some water and put it on there. There's all sorts of different things that you can try, and then you just match it up with the number on there and see whether it's an acid or an alkali. That's all our experiments finished now, so I'm going to take a look at my chromatography. Let me hold it up so that you can see it. Now, hopefully you can see there's some dark blue, some light blue, some purple, some pink, all sorts of different colours inside that blue pen. And the really cool thing is that's just that blue pen. There might be a different blue pen made in a different factory that's got a completely different mixture of colours hidden inside it. Normally, when we're writing with it, we just don't know what's in there. The only way we can find out is by doing chromatography. If you run out of chromatography strips and you still want to do some more chromatography, you can actually use kitchen roll or toilet roll. It's a bit more breakable, so it's a bit harder to do it. You've got to be very, very gentle if you do it with toilet roll or kitchen roll, but you'll normally get a little bit of chromatography happening. You just have to do exactly the same thing. Draw a little bit on a sheet of toilet roll or kitchen roll, and then put the end of the toilet roll or kitchen roll in some water and let the water work its way up to the top of the piece of paper. So we've done chromatography, diffraction, we've managed to put those colours back together again, and then we found out if something was an acid or an alkali. Hopefully you've enjoyed yourself, or if you haven't got the kit yet, hopefully you will, and hopefully you will enjoy yourselves, and hopefully I'll see you again soon for some more science.